Hey, what's up? It's your old pal, Mr. Cook. We're going through the AP Calculus BC Unit 8 Part 3 test review. And let's see, looks like we got 2 pages worth of stuff, 7 questions. First video, we'll probably do the first 6, and then last video, we'll do number 7. So 2 videos this time. All right, so we start off with some vector algebra. We're just going to be adding 3 vectors together and multiplying numbers on them. They call these numbers that we multiply on them scalars. Excuse me. And they just distribute into the terms that we have. So we have 2a minus 3b plus 5c. It's going to be equal to the following. It'll be 2 times a, which is negative 3 and 6. Minus 3 times b, which is 2, negative 3, plus 5 times c, which is 1 and 5. Then we just distribute the scalar value in there. And then we add up the component parts. So we distribute the 2 in there, we end up with a negative 6 and a positive 12. And then distributing in that negative 3, we get a negative 6 and a positive 9. And distributing in that 5, we get a 5 and a 25. Okay, now we add up all of the x components. That's all the first terms. So negative 6, and positive 5. That makes a negative 7 overall. 12 and 9 is 21. 21 and 25 makes 46. So negative 7, 46. That's what we end up with. Okay, next up, we've got to find the magnitude of some vector b. The magnitude, that's what these little bars represent around it, does not mean absolute value. The magnitude is, another way to write it is with these little double bars here, the magnitude of the vector b. It's just like the length of the vector, okay? And you can find it just using Pythagorean theorem, essentially. So the magnitude of the vector b, what we do is we take the square root of the components of b, so 2 and negative 3, and we square them and add them together. Okay, so we got a 2 and a negative 3, and then 2 squared is 4, negative 3 squared is 9. I guess we got a square root of 13, but honestly, if you left it like that, I'd probably be okay also. You'd probably get full credit at that point. For 3, we are given some vector valued function. And this just says, hey, plug in negative 2. So you just do that. Plug in negative 2r of negative 2. And then plug it in. You get 5 times 2 squared minus 2. And then, oops, wait, that should be a negative 2. I'm sorry about that. There we go. Negative 2. And then e to the negative second. And then the sine of 2 times negative 2. All right, so then let's see. We multiply that stuff out. We get negative 2 squared is 4. 4 times 5 is 20. Plus 2, that's 22. And then this other stuff, I'd probably just leave it as is. E to the negative second and the sine of, well, maybe I'd change that to like a negative 4. I don't know. And then leave it. There you go. There's full credit for that vector. Next, we got to find the position vector with this other wacky stuff in there. So we're just going to plug that in for t, wherever we see a t. So r of this vector, this vector at t equals 2m minus 3n is going to be equal to, and then we just plug it in. So 5 times 2m minus 3n squared minus 2m minus 3n, comma, e to the 2m minus 3n plus the sine of 2 times 2m minus 3n. There we go. There's our little vector. And you can just leave it like that. You don't need to simplify it in any way. Just leave it like that and we're good to go. Okay, a couple more and we're done with this video. This one says find the velocity. If we have a position vector, then the velocity is just the derivative. So velocity of t, or velocity of some object at time t is going to be equal to the derivative of r, the vector value function for r. So if we take the derivative of 3 sine t, that's going to be 3 times the cosine of t. Derivative of cosine is negative sine, so we get a negative 2 sine of t. And I think that's it. So I just got to do is just write it as v. Next, it says define two vectors, r and v. So for r, right, we just got to plug in 2 pi over 3 for r, in this equation. Okay, so, plug it in for t in the r equation. So r of 2 pi over 3, just use your unit circle values on this one. We get, let's see here. Well, first you can just write it like this, 3 and then sine of 2 pi over 3, comma, 2 cosine of 2 pi over 3. And if you just left it like that, you'd be right. That's your vector. But we're going to need that in a little bit. So we'll say what those values are in a second. Okay, now we need the velocity vector for 2 pi over 3. So I just plug in 2 pi over 3 to my velocity components. So that would be a 3 cosine of 2 pi thirds, and also negative 2 times the sine of 2 pi over 3. There we go. There's our little velocity vector. And we're done. That's all you need. Just write it in. Next, number 6, sketch the plane curve for r. And make sure I write r of t over here so I can have access to it on the screen. 3 sine of t. It's not out of my view. 2 cosine of t. There we go. Okay, sketch the plane curve. What that means is just graph the equation that you get from these parametric values. And if you have your calculator, which you will have on the test, you just graph it out, in parametric form. Otherwise, you can just do what I do and just kind of graph it out by hand. It's not that bad. All right, so that's what I'm going to do. I'm going to graph out this plane curve using this. So since I have sine and cosine, really good numbers to plug in for sine and cosine are 0, pi halves, pi, 3 pi halves, and 2 pi. Because it gives you like a full range of values to plug in, and they're always ones and zeros for sines and cosines. So let's see what happens when we plug in 0. So the sine of 0 is 0, and 3 times 0 is 0, so we get 0 for the y. And if I plug in 0 for t here, 2 times the cosine of 0, well, cosine of 0 is 1, and 1 times 2 is 2. Next, if I plug in pi halves, sine of pi halves is 1, so 3 times 1 is 3. And then the cosine of pi halves is 0, so 2 times 0 is 0. And then if I plug in pi, so if I plug in pi over here, sine of pi is 0 again. And then cosine of pi is negative 1, so 2 times negative 1 is negative 2. If I plug in 3 pi halves for this guy, I get negative 3. And then for the other one, I get 0. And then at 2 pi, I'm back over at 0, 2. So here's how my vector valued function is graphed out as a plane curve. What I do is I just graph the coordinates. So starting at the origin, I go over to 0, 2. So going over 0 and then up 2. So that puts us at this point. So I'd have a vector, for that, from the origin over there. Then 3, 0. So I go over 3. And I just need the points so I can graph out this equation. 0, negative 2. And then finally, negative 3, 0. And, since I went in order, 0 to pi halves to pi to, and all that, I started here. I started going this way. This vector valued function goes in this direction, okay? Just like, how I draw out our little parametric curves with the arrows. Okay, there you go. There's the parametric, the vector plane curve. Next, we got to draw the vectors at specific points. And this is where we got to go back to like the calculations that we did over here and just find out what those numbers actually are. So 3 sine of 2 pi over 3. Well, the sine of 2 pi over 3 is square root of 3 over 2. So this becomes 3 square root of 3 over 2. And then the cosine of 2 pi thirds is negative 1/2. So negative 1/2 times 2 gives me a negative 1. So like this is how my vector is going to look. It's going to go out by 3 square root of 3 over 2 and then down 1. But I can actually like kind of just look at my curve that I have. And if you trace it over to where the y value is equal to negative 1, like right here, so that's associates with like that point on my curve. So I can just draw a vector going from the origin directly over to that point, and that's my vector, okay? Because I know for a fact that at that point right there, that's where the y value is equal to -1. So that's how I know what it is. I don't really care what that number is. I know it's positive, so it's going in the x direction, positive, but it's right there basically, okay? Okay, next I'm going to draw the vector the vector for velocity. So for the vector of velocity, well, there's a couple things from this. So cosine of 2 pi over 3 is, again, -1/2. So we get, like, it looks like a -3 over 2 for that. And then the sine of 2 pi over 3 is still going to be square root of 3 over 2. So I get -2 square root of 3 over 2. And I don't really care, like, potentially, like, what those numbers are, right? I can guess what they are, but like the velocity vector always starts at the end of the position vector for that time, and then it follows this direction. Now, all you have to do to draw the vector is not be really accurate with it, but just kind of know the general direction of it. Since this x value is negative, that means that it's going to be going to the left, so my vector is going like that way. And then since my y value is also negative, that means it's going to be going down. So that means that the vector is going to be going like that, okay? It's going down and to the left from, the position vector. And that should make sense, right? Because the velocity, the position has it moving, like when it starts here, it's like moving this way along the curve. So of course its velocity is going to be going down and to the left to fit that orientation of the graph. Anyway, so that's all that you need to do for graphing it. And that's it. So yeah, that's the end of this page also. So I'll stop this video now. If I hope you found this helpful, and if not, just go find your calculus teacher, get some help from them. You know me, I'm Mr. Cook. I'm available before school and after school, so just come and find me. And if you need some help, I'll help you out. Okay. Thanks again for watching this video. I hope you enjoyed it. See you in the next one. Bye-bye.